Today we will make predictions about a population. So the activity that we're doing today, it relates to this unit that we're in, the data analysis unit, but it's something that we've already covered when we covered probability this year. So we're going to be making predictions about a population. Now, if you look on the side here, or it says for exercise 1 through 4, use the table and the following information. A survey of students' favorite sports was taken from a random sample of students in a school. The results are shown in the table. So if we look here at the table on the side, this shows us the students' favorite sport. And we're going to use this information to make some predictions and to make some comparisons. And in the process of this, we're going to be making some part-to-whole comparisons and part-to-part comparisons, which we've been doing lately. First question is just kind of setting up our thinking. What is the size of the sample? When we talk about this word sample as it relates to populations, it means when you take like a small piece of the population, almost like a snapshot. So just think about, I might have about 140 students, but if I wanted to take a sample, maybe I would just take 10 of those students. And usually when we take a sample, we don't want to like handpick the students. We want to randomly select them so that it doesn't bias our information. For instance, I might take the first 10 students to walk into class instead of going and picking them myself, because if I pick them myself, maybe I'm going to pick the shorter students, or maybe I'm going to pick the female students, right? And so whenever we take a sample, we usually want to take it randomly. So what is the size of the sample? All we're going to do in order to determine the size is we're going to add up all of the students that they surveyed here. And if you look, there's 8 plus 3 plus 5 plus 4. So that's 11 plus 9. There's 20 students. So the size of the sample is 20 students. Then it wants to know, what is the probability that a student will prefer soccer? So if we think back to probability, we're talking about the number of favorable outcomes over the number of possible outcomes. Now, in this case, we're looking for the students that prefer soccer. So if you notice, there's 8 students that prefer soccer. Over the possible number of outcomes, we know that there's 20 outcomes or 20 students here. So 8 over 20. Then we're going to simplify this. We always want to express our fractions in the simplest form. So we're thinking to ourselves, what's the greatest common factor between 8 and 20? What's the biggest number that we can divide both of those by? And it's 4. 8 divided by 4 is 2. 20 divided by 4 is 5. Number 3. What is the probability that a student will prefer volleyball? So again, we're starting off with this probability ratio, the number of favorable outcomes over the number of possible outcomes. And then we're talking about students that prefer volleyball. So I'm going to use a different color actually. Let's use green for prefer volleyball. Let's look at volleyball. So there's 5 students that prefer volleyball out of 20 possible students. And then we're going to simplify that. We're going to divide the greatest common factor between 5 and 20 is 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So there is a 1 out of 4 chance that the students will prefer volleyball, right? Remember, we can also express these as percentages. Most of us should know that 1/4 equals 25%. So there's a 25% chance that a student will prefer volleyball. Now, just talking about converting to percents, just to refresh, we're going to convert this 2/5 over here. This 2/5 over here that prefers soccer that we talked about earlier, we're going to convert that into a percent just in case, just to refresh that skill for you. So one of the ways that we can do it is we could divide 2 divided by 5 and then convert that decimal to a percent, or we can use the percent proportion and then make it into a fraction equivalent to 100, I have to ask myself, what do I have to multiply 5 by in order to get 100? Well, I could either divide it, or I might know that 5 times 20 is 100, so I'm also going to multiply this 2 times 20, which gives us 40. Or 40 out of 100 is the same thing as saying 40%. Sorry if I jumped around on that one. I just wanted to reconnect you with how to convert a fraction into a percent. Now let's go to the last problem. The last problem says there are 550 students in the school. Predict how many students at the school prefer track and field. So this is where we're going to actually make the prediction, right? We're going to use the sample, the probability from the sample that they gave us, and then we're going to write a proportion to make a prediction. So whenever we have a proportion, we're always going to have two equivalent fractions or two equivalent ratios. We're still using the probability ratio, the number of favorable over the number of possible outcomes. So first we need to look at how many students prefer track. We can see that there's 4 students that prefer track out of a total of 20 students. So that's the probability that the problem gave us from the sample. So there's a 4 in 20 chance that a student will prefer track and field. Now we're going to make a prediction based out of 550 students. And then from there, we're just going to cross multiply. So 20 times x, 20x equals 4 times 550, 2,000. So this should be 2,200. Now we have a one-step equation to solve. We're going to divide both sides by 20 to get the x by itself. 20 divided by 20 becomes 1x, or sometimes we just say x. We're going to divide both sides by 20. First, we're going to simplify the zeros out. Then we end up with 220 divided by 2. If we do the math, that equals 110. So what does this 110 tell us? This 110 tells us that there's 110 students that should prefer track and field out of 550 students in the school. So let's recap everything that we just did. Questions 1 through 3 just kind of walked us or reactivated that skill that we were using with probability and being able to get the total number of students. That was the first step that we did. So the problem kind of set us up for that. In number 2, they refreshed us being able to determine probability. So we know that we use the probability ratio every time that we're doing a probability problem, the number of favorable outcomes over the number of possible outcomes. We wrote the ratio, we simplified it, and we did that for number 2 and number 3. In number 4, we used probability in our skill to determine probability to make a prediction. And in order to make a prediction, we wrote a proportion and we solved that proportion.